So 6-4 gets us into the properties of rhombies. We're using rhombuses. I've always seen it as rhombi. I don't like the plural wording on this in this textbook. Just going to tell you that right now. Rectangles and squares. So these are all special parallelograms, and the square is the most special of them all. So really, here's a visual diagram. I know that you started a diagram of all the characteristics, but we start off with the wonderful world of any quadrilateral. So this could have been any quadrilateral. This is general. Then from there, we branch off. We will branch off in two different directions. Our first branching off is the parallelogram. And then what this is going to tell you is that from the parallelogram, we're going to branch off again in two different directions. One direction is going to be the rectangle. We have 4 right angles, and opposite sides are going to be congruent. And then we're going to have the rhombus. Okay, we'll draw the rhombus, where all sides are equal and are parallel. So this is your rhombus. This is your rectangle. And this is a love story. The rectangle and the rhombus fell in love. And they created a love child. And the love child is known as the square. Because the square contains all of the characteristics, and it's hard to see. The square contains all the characteristics of the rectangle and the rhombus. And all 3 of them belong to the parallelogram family, so if you get too into my story, it's a little incestuous, but we won't go there. What can I say there? Let's call them fifth cousins removed to make us feel better. But my point is, these both contain every characteristic of the parallelogram, but they have additional special characteristics that make them unique. The square contains all of the characteristics of the parallelogram and the characteristics of its mommy and daddy, rectangle and rhombus. So the square is the most unique quadrilateral of them all. The square contains all of the characteristics of quadrilaterals, parallelograms, rectangles, and rhombies. And so you need to have them straight in your head. So today is the day that you become candidate. If you don't know what's in a parallelogram, no head should be on a desk. Nobody should be slouching. Everybody should be up straight listening. If you want to sleep, go home. Go home. Don't come to school. You're not accomplishing anything by sleeping on the desk. So let's just start with diagonals. What did you say was a diagonal in the picture? Is AG? The sideline, so no. How about AC? Also a sideline. How about HD? No, why? Goes through the middle. It's not through the vertices, right? So that's out. GC? Yes. How about EF? Best friend? How about AE? Yes. How about EG? Sideline? No. How about EF? Half of the sideline. Oh, all right. Is a diagonal ever a line or a ray? Wow. Technically not. So we're going to go with a technical word no. it's really a snapshot of a line or array, but because otherwise it has no end. There's no way to measure. You have to be able to measure our diagonal. The diagonals of quadrilateral JALM are, well, if I were you, and you could actually do it without drawing a diagram, but let's just go ahead and draw a rectangle. I'm going to label it JALM. So again, if you start here at J, you have to go clockwise or counterclockwise, but I cannot put K directly opposite of J because they are consecutive, one right after the other. And so my diagonals would be those two, JL and KM. How can I find the diagonals without drawing the picture?
Look at the letters.
And how do I figure it out? By looking at the letters. The diagonal is never drawn from one consecutive angle to another. So J and K are next to each other in the name of the quadrilateral, so they are consecutive angles. So J and K cannot be a diagonal. So it would have to be JL and it would have to be KM. So you can't do it without drawing a picture. So let's start with our rhombus. Go to my highlighter. So a rhombus is a parallelogram with 4 congruent sides. So take your paper that has all of the characteristics on it, and we are now going to add to that the characteristics of a parallelogram. Or I'm sorry, a rhombus. Didn't they just define a rhombus for us? The definition is a characteristic of the rhombus. So what did it say? It is a parallelogram with 4 congruent sides. So the minute your parallelogram has all 4 sides equal, because in a parallelogram only opposite sides have to be equal. But the minute that all 4 sides are equal, it's impossible to not have a parallelogram, by the way, if all 4 sides are equal. So now we have a rhombus. So here's a bunch of questions that I love to put on tests. So before we can answer these, let's kind of finish up. Well, we can actually use this right here. So I'm going to zoom out. So use your love diagram up there. All right, so here's our diagram. A rhombus is always, sometimes, or never a parallelogram. What do you think? Well, it's underneath the parallelogram, so anything underneath contains always the same attributes as what's above it. Anything below it, it may or may not. So this is always. A rhombus is always a parallelogram. A parallelogram is sometimes, always, or never a rhombus. Because it's below, that would be a sometimes. Sometimes it is, sometimes it's not. It only becomes a rhombus if all 4 sides are equal. So this is sometimes. You might want to study this one. A rectangle is sometimes, always, or never a rhombus. It actually is sometimes. I know that they're directly across from each other, but when would a rectangle, well, I guess it depends on how you actually consider this. Is a square a rectangle? So a square is a special rectangle. So technically, if we're talking about a square that is a special rectangle, then it will be a rhombus. But if the rectangle is not a square, it will not be a rhombus. So my opinion on this, which could be argued, is sometimes. Since I'm giving you the test, but sometimes. And you might always qualify that with, but sometimes, and then in fact you could say only when, and this would be a good thing, only when a rectangle is a square. How do you know? A square is sometimes, always, or never a rhombus. It's below it. So it is always. Square belongs to the rhombus family. It belongs to the rectangle family. It belongs to the parallelogram family. A rhombus is sometimes, always, or never a square. Sometimes. Only when, and you'll find out, only when we have 4 right angles. So sometimes. A rhombus is sometimes, always, or never a hexagon. What's a hexagon? 6 sides. So can a rhombus that has 4 sides be a hexagon? No. So this is actually. All right. So here they're trying to give you a diagram just like I gave you before. So we have our definitions, key concepts. A rhombus is a parallelogram with 4 congruent sides. So we already did that. Whereas a rectangle is also a parallelogram with 4 right angles. So that's what makes, that's the difference between your rhombus and your rectangle. So over here, we have our rectangle. Its definition is, it is a parallelogram with 4 right angles. It still has opposite sides parallel, opposite sides congruent, diagonals bisect. It still has all the same characteristics as a parallelogram, but the difference between a rhombus and a parallelogram is 4 right angles. And then your square is still technically a parallelogram, but it contains these 2 qualities from mom and dad. It's got 4 congruent sides and 4 right angles. And so that's our last piece, although save some room there because we've got, so a square is a parallelogram with 4 right angles and 4 congruent sides. But some special things also happen due to these additional characteristics. Even if I have to ask you one more time, you're going to go to the office. So you make the choice to stay awake or not. Alright, so you were to write words rectangles, rhombus, and squares in the Venn diagram below. So special parallelograms. What goes in the middle? This means it is a combination of this one and this one. So out of these 3 words, which one is the combination of the other 2? The square. So the square goes in the middle. And the rectangle will go on 1. And the rhombus on the other. And you could switch the rectangle to rhombus, but the square has to be in the middle. Circle the number of sides marked in the diagram. That's a chart. How many sides are marked? 4. Are any of the angles right angles? What would you have to have there to note that it's a right angle? You have to have a little right angle marker. So you can't just assume, even if you may look at the square, you can't assume. So the answer we know. So is it a rhombus, a rectangle, or a square? Just based upon the information given. It can only be a rhombus. And technically it's also parallel. Then we have some theorems. If a parallelogram is a rhombus, then its diagonals are perpendicular. So there is a characteristic. So if we have a rhombus, all of a sudden the diagonals become perpendicular. Right there, the minute I know that all 4 sides are equal, then we're going to add to our characteristics over here that the diagonals are perpendicular. It does not happen in a rectangle unless that rectangle is a square.
Is that for rhombus?
Correct. The diagonals are perpendicular the minute it becomes a rhombus. Then it says, if a parallelogram is a rhombus, each diagonal bisects a pair of opposite angles. So that's what we're talking about today. So another characteristic of a rhombus. The diagonals bisect the opposite angles. Now bear in mind that the square contains these characteristics as well because it's also a rhombus. So all these characteristics that I'm adding to the rhombus belong to the square as well. Just like it has all those characteristics of that parallelogram. So the square is the most characteristics of all. It has about 10 characteristics. A lot of things to know. And so, what that tells us here is that angle 3 is congruent to angle 4, and since opposite angles are congruent, these angles are also congruent. And then, angle 1 is congruent to angle 2, and because opposite angles are congruent, angle 6 is congruent to angle 5. So you end up with 4 little right triangles in there that they'll like to use Pythagorean theorem on a lot. And so we're not going to fill all these out because we just tick one of them off. So we flip, you good with that? Alright, so look at problem 2. What are the measures of the number of angles in rhombus PQRS? So the fact that they told us a rhombus tells us a lot. Everything that's true about a parallelogram is true here, plus the 3 characteristics are up there. 4 sides are equal, diagonals are perpendicular, diagonals bisect opposite angles. So, circle the word that describes triangle PQR, and PRS. What do you know about all the sides on this rhombus? All the sides. The 4 sides on a rhombus are what? They're congruent. So I can single tick mark each of those sides. And then this diagonal is shared by the 2 triangles. It definitely is not the same as the other 2. So what kind of triangles are these 2? Isosceles. Circle the congruent angles in PQ1. So we're going to circle them in their pairs. So we have this 104. Is there an angle congruent to the 104, which is angle Q? Opposite angles are congruent, right? So Q and S are congruent. So those are congruent. And then what about these 4, 1, 2, 3, and 4? What do you know about them? Overall, isn't the whole angle from here to here congruent? And then on top of that, isn't the angle bisected by the diagonal? So aren't all 4 of them equal? So all of these are congruent to each other. So you actually have 4 little angles in there that are all congruent. It's important that you realize that. So what is the measure of angle 1, angle 2, and the 104 added to it? Angle 1 and angle 2 and the 104. If you put angle 1 and 2 together, they make the whole big angle P. What do you know about the whole big angle P and angle Q? They're supplementary because they're consecutive angles in a parallelogram, right? So I know that those 3 would add up to 180. It's important that you realize that as well. We might be able to use that information later. And wouldn't that be the case also for 1, 2, and angle, well, what is 1 and 2 equal? 76. How'd you get that? So she subtracted 104 from 180, and so we got 76. Very good. And then so how do we know the measure of angle 1? Divide by 2 because these are equal, right? So 76 divided by 2, 35 plus 3 would be 38. Each diagonal of the rhombus does what to a pair of opposite angles? What does this diagonal do to the opposite angles? Does it kiss them? How can you bisect them? Just wondering if you were all paying attention. Circle the angles in rhombus PQRS that are congruent. We already did all that right there. We already discussed that. Came to that conclusion earlier. So they're all congruent. And so if we know that the measured angle 1 is 38 degrees, aren't all of them 38 degrees? 38, 38, 38, and 38. So that's how we're able to find each of those numbered ones just knowing the 140 degrees. We have another theorem. If a parallelogram is a rectangle, then its diagonals are congruent. Now this is one you're going to get mixed up with a parallelogram all the time. The diagonals in a plane parallelogram are not congruent. They bisect each other, but they're not congruent. So the nice thing about a rectangle is if the diagonals are congruent and they bisect each other because it's a parallelogram, then the 4 pieces of the diagonal that are created by that become equal. And look what happens. So down here, here's a rectangle. They tell you it's a rectangle. Here's your diagonals. If the diagonals themselves are congruent and they bisect each other because it's a parallelogram, all 4 of those pieces, that's a single thing, all 4 of those pieces are equal. And it creates 4 isosceles triangles inside here. Now, I will grant you, look at, because these sides are not the same as these sides, these are congruent, and these are congruent, but all 4 they're not. You don't get 4 isosceles triangles that are congruent. You get these 2 are the same, they're congruent, and these 2 are the same. So that's another thing you want to remember is all your triangle knowledge. So if Ln, the distance from L to N is 4x minus 17, so let's write that in there. This whole distance is 4x minus 17. And MO, this whole distance here is 2x plus 13 from here to here. What are the lengths of the diagonals of the rectangle? So what do we know about the diagonals themselves? They're congruent. So I'm going to take these pieces, 4x minus 17, and set it equal to 2x plus 13. If you don't have those characteristics in your brain, it's hard to take them out of your brain and use it to solve an equation. And so we're going to solve by subtracting 2x. So we get 2x minus 17 is equal to 13. Add 17. And we get 2x is equal to 30. So x must be 13. Does that answer the question? They want the length of the diagonals. So I need to plug that back into one of these 2. If I were taking a test, I'd plug it back into 12 of them. I'm not, so I'm plugging it into 1. So 2 times 15 is 30, plus 13, which is 43. So the length of one diagonal, actually of each of the diagonals, is 43 units. And in the back is just the lesson check. And so we'll just leave that. We won't do that one. Yes?
Is that due tomorrow?
Yes, that will be due tomorrow.